Good morning, students. I am Gopal, head of the Department of Humanities and Science. Now today we are going to discuss partial fractions. So in previous classes we have to combine the two or more fractions into a simple fraction. And here, so we split the given fraction into two or more the simple fractions is called a partial fractions. So before going to discuss the partial fraction, first we have to define one of the definition, that is polynomial. So an expression of the form a0 x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 and so on, an x power 0 or an, where n is a positive integer and a0, a1, a2 and so on, an are real numbers, is called, means this expression is called nth degree polynomial in x. Nth degree means what is the highest power of x in this expression. So highest x power is n. So therefore the given polynomial is said to be nth degree polynomial, and here this polynomial is in terms of x. So that's why it is said to be a nth degree polynomial in x. And we are taking one or two examples. Example 5x to the power of 6 plus 4x to the power of 5 plus 9x to the power of 4, 10x cube plus x square plus 3x plus 4. So this expression is said to be a polynomial. So this is a polynomial in x. What is the highest power of x here? So highest power of x is 6. So therefore this is said to be sixth degree polynomial in x. And we are taking one more example. This is the first example, and example 2, 3x cube plus 4x square plus 5x plus 7. And this is a polynomial of degree 3. Why? Because the highest power of x is 3. So therefore this is third degree polynomial. And we are taking one more example here, x square plus 2x plus 3. This is also be a polynomial of degree 2, means this is second degree polynomial. Okay, now this kind of expressions are said to be polynomials, and by based on this variable power, so this is said to be a degree of polynomial. It is in x. So polynomial in x and polynomial in x. We are taking one more example here. A fourth one, z cube plus 4 z square plus z plus 2. So it is also be a polynomial. Students, the next definition, rational fraction. If f of x, g of x are two polynomials. Already we discussed what is the polynomial. Here we are taking f of x and g of x are two polynomials, and g of x is not equal to 0, right? So then f of x by g of x is called a rational fraction. So here we are taking two polynomials. If f of x, g of x are two polynomials where g of x not equal to 0. So then f of x by g of x is called a rational fraction. In case g of x equal to 0, what happens? So f of x by 0, so this is becomes undefined. So that's why here we are taking this condition, g of x not equal to 0. And we have to return one or two examples here. Example 1, x square plus 1 by 3x cube 4x square plus 2x plus 1. This is the first example, and we are taking the second example. Example 2, x by x square plus 2x plus 3, and we are taking one more example. Example number 3, x square plus 2x plus 3 by x square plus 5x plus 6, right? And we are taking one more example. Example 4, x cube 3x square plus 4x plus 5 by x square plus x plus 1. Yeah, these are the examples. Now we check it. This is f of x, and this is g of x. In this example, this numerator is f of x and this is g of x. And in this example, this is f of x and this is g of x. And this example, this is f of x and this is g of x. Now coming to the first example, this is f of x. What is the degree of this f of x? Degree is 2, and in the denominator, this denominator is said to be g of x. What is the highest power here? Means what is the degree of g of x? The degree of g of x is 3. And coming to here, degree of f of x is 1 and degree of f of x is 2. And coming to this example, degree of f of x is 2 and degree of f of x is 2 and degree of g of x is also 2. And coming to this example, degree of f of x is 3 and degree of f of x is 2. And students, please observe. So here f of x degree and g of x degree. Students, now the rational fraction is classified into two types: proper fraction, improper fraction. Okay. So if, for example, one rational fraction is given, so how to classify the given fraction, either proper or improper? So in last example, we have to see examples. We are taking one example here. X square plus 2x plus 3 means x by x square plus 2x plus 3. Here the degree of f of x is 1, degree of f of x is 2. So here, if degree of f of x is less than degree of g of x, so then f of x by g of x is called proper fraction. Okay, now this is the example. So what is the degree of f of x here? Degree of f of x is 1 in this example and degree of g of x is 2. So therefore degree of f of x is less than degree of g of x. So therefore these kind of fractions are said to be proper fractions. So degree of, if degree of f of x is less than degree of g of x, then f of x by g of x is called a proper fraction. And coming to the improper fraction, if degree of f of x greater than or equal, either greater than or equal to the degree of g of x, so then f of x by g of x is called improper fraction. Okay. So in this expression, in this rational fraction, degree of f of x greater than or equal to degree of g of x, then the given rational fraction is called improper fraction. We are taking the two examples. Example 1, x square plus x plus 1 by 3x square plus 4x plus 5. So here degree of f of x is 2 and degree of g of x is also 2. So therefore the given rational fraction is improper fraction. And coming to here, the degree of f of x is 1 and degree of g of x is 2. So therefore degree of f of x is less than degree of g of x. So therefore it is said to be proper fraction. This is improper fraction. Why? Because degree of f of x is equal to degree of g of x. And the second example, x cube plus x square plus x plus 1 whole divided by x square plus 1. So what is the numerator here? This is the numerator and this is the denominator. Degree of f of x is 3 and degree of f of x is 3 and degree of g of x is 2. So therefore degree of f of x is greater than degree of g of x. So therefore this fraction is improper fraction. So dear students, now the rational fraction is divided into the two types. First one is proper fraction, second one is improper fraction based on degree of f of x and degree of g of x. Now first one, in this rational fraction, degree of f of x is less than degree of g of x. So therefore the given rational fraction is said to be proper fraction. And degree of f of x greater than or equal to degree of g of x, then the given rational fraction is said to be improper fraction. Okay. Now these are the examples. These are the examples of the improper fraction, and this is the example of proper fraction. Okay. Now students, now we have to check it. The following fractions are proper or improper. Now this is the assignment. Now the first problem is 1 by x square plus 2x plus 3, and now we have to check it. Numerator highest, numerator degree and denominator degree. Here numerator degree. So 1 means actually this is x to the power of 0. No problem. Here x to the power of 0 means 1. So therefore the numerator degree is 0. Now it means this is 0 degree polynomial and this is second degree polynomial. So therefore 0 is less than 2 means degree, this is the degree of f of x and this is degree of g of x. So therefore degree of f of x is less than degree of g of x. So therefore according to the definition of the proper and improper fractions, this is proper fraction. And coming to this one, what is the numerator degree? The numerator degree is 1 and denominator degree is 2. So therefore degree of f of x is less than degree of g of x. So therefore this is also proper fraction. And coming to this example, now check it, this example, x square plus 3x plus 4, 5x square plus 3x plus 4 means the numerator degree is 2 and the denominator degree is 2. So therefore degree of f of x is exactly equal to degree of g of x. So according to definition of the improper fraction, if degree of f of x greater than or equal to degree of g of x, then the given rational fraction is said to be improper fraction. So therefore according to definition, this is improper fraction. And coming to this example, so this is x cube plus 2x plus 1 by x square plus 1. Degree of f of x is 3 and degree of f of x is 2. So therefore degree of f of x is greater than degree of g of x. So therefore this is improper fraction. Improper fraction. Okay. Now this is the degree of f of x is 9, degree of f of x is 7. So therefore degree of f of x is greater than degree of g of x. So therefore this is improper fraction. Now this one, this is proper or improper? Yeah, now we check it. This is degree of f of x is 4 and degree of f of x is 4. So therefore this is improper. And coming to this one, so actually now we multiplying this denominator. So we getting this is x square plus 2x plus x plus 2. So finally this is x square plus 3x plus 2. So means degree of f of x is 0 and degree of g of x is 2. So therefore this is proper fraction. And coming to this one, yes, this is x into x means x square. Degree of f of x is 1 and degree of g of x is 2. So therefore this is proper fraction. Yeah, now this is the, so identify, so now this is the process of identify the given fractions, either proper or improper fraction. Now students, now this is the actual definition of the partial fractions. Expressing a rational fraction as the sum of two or more simple fractions is called resolving a given fraction into partial fractions. Means the given rational fraction expressing as the sum of two or more simple fractions, so is called resolving the given fraction into partial fractions. So in next class we have to discuss the method of resolving the given fractions into partial fractions. So resolving the given fractions into partial fraction, we have two or three methods. Now depends on the g of x, means in the given rational fraction we have the numerator and the denominator. So this is the denominator. By the based on the denominator we have the methods. Now in next class we have to discuss the methods of resolving a given fraction, rational fraction into partial fractions.